Hi everyone. Thanks for joining me today. It's January 2nd and Happy New Year. Today's video is on the contents of the Fukushima Daiichi contaminated water tanks. To date, there are 1,061 tanks on site. 1,002 of those tanks are used for the storage and treatment with the ALPS system. 45 of those tanks are being used for the cesium-strontium treated water. 12 of those tanks are being used for the freshwater treated with the RO facility, and 2 tanks are being used for concentrated seawater, and that's as of December 17th of 2020. Broken down at the rate of filling 1 tank per week of the 1,002, that would roughly make 500 tanks of 100% untreated water. That leaves roughly 500 for the 2 stages of the ALPS treatment. Therefore, 250 of the first treatment and another 250 for the second treatment. That leaves 307,500,000 liters of untreated water still left to be touched. This is TEPCO's portal for just the tanks alone, so you can specifically seek out this site and they will show you everything you need to know about these tanks. Well, most of what you should know. I will cover the rest. Okay, now we want to stay in Chrome here. Okay. No, actually we need to find the TEPCO PDF. So let's go find the TEPCO PDF. This is TEPCO's PDF that they put out for the water for the second stage of the ALPS system. I'll let you guys read this. You guys can go seek out this site and this will bring you right to the PDF. Notice that for one tank full, there needs to be 3 separate tanks made. That's one issue with why they don't want to build more tanks and just store it on site, because it would be a massive amount of tanks, but there's plenty of room for that amount of tanks still there. The exclusion zone is massive. These are the graphs from where they say the levels of the first treatment were, and the arrows indicate what the levels are after. And notice tritium is all the way to the right. There are things that must be pointed out here, and the obvious should jump out to some. I want everyone to look at the half-life in parentheses. The half-life all the way to the left, it says nuclide and half-life in parentheses. Notice that every one of these say approximately. This factor is overlooked by most, but means so much. A single word. What could a single word prove? Approximately. Well, let's go see what approximately is. So this is the list of nuclides. And we'll read this short little section here. The list of nuclides shows observed nuclides that either are stable or, if radioactive, have half-lives longer than 1 hour. At least 3,300 nuclides have been experimentally characterized. See list of radioactive nuclides by half-life for the nuclides with decay half-lives less than 1 hour. A nuclide is defined conventionally as an experimentally examined bound collection of protons and neutrons that either is stable or has an observed decay mode. As we scroll down here, I will point out a few things here, but you guys can find this in your Google search. And we will move down to the legend. And we'll start at the energy column. The column labeled energy denotes the energy equivalent of the mass of a neutron minus the mass per nucleon of this nuclide. So all nuclides get a positive value in mega electron volts. So allow us to look at mega electron volts here. The electron volt. In physics, an electron volt, symbol EV, or mega electron volts, MeV, is the amount of kinetic energy gained by a single electron accelerating from rest through an electric potential difference of 1 volt, and most importantly, in vacuum. In a vacuum. That is a very important part that is overlooked. And as I show on YouTube, the inverse square law also only works in a vacuum and does not apply to extended sources of radiation. This shows that the two very factors used in mass spectroscopy only works in a vacuum and do not apply to the surface of this planet, and exactly why all interactions that take place can't and haven't been able to be seen, and why our atmosphere and oceans change those factors than what the formulas suggest. Only a vacuum will show the true intensity and duration of an electron volt. Only in a vacuum can the formula intensity equals 4 times pi times r squared, that's 4 times pi times r squared, can be used to expect the correct outcome. This is the same for every radiation detection device, proven not just through NIST and the Bureau of Standards, but corroborated by the medical professionals using the same materials and devices for the cancer treatments. They use the very same nuclides and devices used as what comes from nuclear reactors. Yttrium-90. They use these things to kill the cancers that were more than likely caused by these things. With water solubility, evaporation under equilibrium conditions. Okay? And then bonding with molecules such as, but not limited to, oxygen 16 and 18. And then the warming oceans that have evaporated more oxygen 18 than in times past, meaning that more of the heavier bonded molecules are evaporating. And a water cycle that absolutely caused this all to move around the planet. That's why they've developed a set of formulas that they use to try to get an idea of what's happening when it moves into an environment. These are the concentration ratios that you see. Let's explain it this way. First line, concentration ratios are used in most radiological models to predict whole body radioactive or radionuclide activity concentrations. They use these for wildlife. Different factors for different animals changes these. So they're using math and statistical analysis to justify what is being distributed into the field. Now we will move on to a spreadsheet that I've transferred these numbers here This is TEPCO's spreadsheet. And I'll show you the group that I used, which is the J1-C group numbers. And you'll notice over here on this right side where the notes are, you'll see things like in radioactive equilibrium with cerium-144. That just means that the daughter of the parent is decaying at the same rate as the parent is decaying to that daughter. Understand? And you'll see things such as assessed using the radiation concentration of europium-154. These are the energies that they are assuming that occur because of something else occurring. Okay? We'll continue to show the rest of them so it is on record what the numbers are. And it can be checked that these are the correct numbers and transferred over. So these are the numbers that I used for my spreadsheet. Okay. And up at the top, you'll notice that what I used was the becquerels per liter from the first and the second treatment. And the only added factor here, the only added column is what's in red, which is the amount per tank. So that would be becquerels per 1.23 million liters, which is what one tank holds. As you follow the red column down, you'll notice there are some issues. There are some things that aren't put in that should be put in. That either the person plugging in these numbers didn't calculate right or didn't put in ND, which is non-detectable because we'll go down and show the legend. Okay. A black asterisk means level shown below detectable limit of detector. That means that their detectors cannot see the amounts and levels below a certain point. The colored in columns are levels above 1 million becquerels in each tank. That means the total in each tank is above 1 million becquerels for that specific one. And the red ones with the asterisks are the levels that are below or are either at or below the total, because they can't see below that amount. So they're either at or below. And as I explained, this is why this has to happen, because estimates and approximations are being used when perfection is required. Okay, now I'll go down and show slowly these numbers. So if they want to be challenged, they can. The half-lives are all the way to the right, where they should be, next to where the becquerels are. And we'll get down to the bottom and see the total, what the total is in one tank. This is very on the fly. I have some notes prepared, but it's turned into something on the fly here. Now you'll see it down at the bottom is the total becquerels per one tank. That reads 271,945,435.51 becquerels per tank. Knowing that there is roughly 250 tanks that have the second treatment of the ALPS, you times that number by 250, and what you are left with is 67 billion with a B, 986 million with an M, 358,877.5 becquerels in those 250 tanks out of the 1,000 at the site. Surely no one in the world really thinks this is acceptable. to release into the ocean, especially knowing the way they attempt to justify it through concentration and ratios. Shame on them, and shame on us if we don't make certain that that water isn't dumped. The only reason they want to dump it so quickly is so that a daughter doesn't decay into another daughter and bring up the levels above safety standards. Then they would have to do the entire process of running it through the ALP system again and build an entire new tank to hold that water, and would be a fourth tank in that series of 3 that lead us to these numbers that we are now. That is what it's about. Nothing more. Thanks for joining me. Like, thumbs up, comment below, and check the description box for links. Thanks, guys.